Hi, I'm from Social Research Insights, and this videocast I'm going to explain you how to do the regression. The mission of Social Research Insights is to promote open source software for data analysis for both academic and corporate research needs. And this videocast I'm going to explain you how to do the regression analysis in LibreOffice Calc installed in Ubuntu version number 14.04. Both LibreOffice Calc and Ubuntu are free software. You can just go to the respective websites, download and install the free of cost. They are very much powerful in doing the statistical analysis. First I'm going to explain you what is simple linear regression, and after that I shall do the same in LibreOffice Calc. The usual expression for the simple linear regression, that y is equal to beta naught plus beta 1 multiplied x, where y is the dependent variable, x is independent variable, beta naught and beta 1 are the regression coefficients, where the beta naught is an intercept and beta 1 is a slope. We have wonderful functions in LibreOffice Calc to compute these coefficients given two data variables, namely x and y. So the other important term which we missed in this expression is error, and I'm going to explain or talk about this error term in a separate video. I also have some certain stuff as how to test the significance of the error through chi-square test, but I'm going to explain you that in a separate video. In regression analysis, all these coefficients can be tested with the help of some certain statistical tests. For instance, if I would like to test the beta naught, the beta naught when divided by the standard error will be approximately equal to t distribution. In the same fashion, when we divide the beta 1 with a standard error of beta 1, this expression will be approximately equal to t distribution. By the same way, when we divide this, when we sum up all the error, the data in the error variable and divide it by the standard deviation, the variance, this will give the chi-square distribution. So this way, in regression, we can test all the coefficients and the other constants. There are separate statistical tests to test the coefficients, the intercept, slope, as well as the error. So I'm going to show you. I'm going to give you a small demonstration as how to do this regression analysis in LibreOffice Calc. For that, I'm going to do that in a few steps. In step number 1, I'm going to simulate the data set. In step number 2, I perform the regression analysis through a special function called linext. This is a special function, linear estimation, which is available in LibreOffice Calc. Instead of doing this manually, we can simply perform the regression analysis by using this function. So I'm going to show you how to do that in LibreOffice Calc. You just have to open the LibreOffice Calc in your Ubuntu, and I'm going to simulate the data set. I call y comma x, and y is the dependent variable and x is an independent variable. I'm going to use two important functions, round and ran, in order to simulate the data variable. I just simply copy and paste for 20 data points, I mean rows, so that we just have to imagine that we got a sample data. The size of the sample is 20, which means I have 20 individuals in my sample and 2 data variables. So this is my sample data, and we are going to do the regression analysis on this data. In order to do that, I need to use, as I said, the function linear estimation, linest. I'm just going to make this data array into static data array instead of okay, now the data points will not change because previously it was a dynamic data array. Now I change it into static data array. So you just have to use the function linest and the independent variable 1 comma 1, which means I need the statistics and the constants and other summary information available through this function. So here this is the beta naught and this is the beta 1, and these are the standard error for the beta naught and standard error for the beta 1, and here we have this r square value, coefficient of determination, and this is f value, and this is degrees of freedom, and these two are the standard error of regression, standard error of I'll show you. I have a screenshot better. So I think now it is easy for you to recognize the values. So these are the constants. This is beta naught and this is beta 1, and this is the standard error for the beta naught, and this is standard error for the beta 1, and this is r square value, which means coefficient of determination, and this is the standard error for variable y, and this is f statistic, and this is degrees of freedom, and at last we have sum of the squares for the sum of the squares of regression, ss reg, and sum of the squares for the residuals, sum of the squares for the regressed value, sum of the squares for the residuals, and these values have importance in this to do some other statistical tests. And if we, as I said previously, if we divide the constant by the standard error, then we'll get the t statistic. So what I do, I just copy these values in a separate place, so that this time I paste special, and now I take them by transposing in transpose order. I transpose the values. I call them as constants or estimates, and paste special transpose, and this should be in reverse order because -2 is beta 1, so 1 comma 2 other values. So I just sort them, go to the data menu, and you have the sort, and take sort A and B in descending order, so you'll get in reverse order. And the same way we also have to paste the other standard error for the beta naught and beta 1. So come here, paste them, paste special, transpose the values. Sorry, I did not copy them. Oh, here. So paste special, transpose the values. Now choose, so data, sort the values, this time ascending because I have already in descending order, so keep ascending. I want to sort the B column, but this I just kept the numbers in C column in order to take the sorter into action. So ascending, yes, so this time you'll get ascending. So now in this column, this is standard error of beta, so paste special, go to the special character and choose the beta here from must be having this symbol somewhere in special symbols. Beta, 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 beta. So this is standard error of beta, and this is t statistic, t measure, which is going to be, as I said in my, so the beta t statistic is beta naught divided by standard error of beta naught or beta hat, and beta t for beta 1 is going to be standard error of beta 1. So we have the standard error, we also have the estimate divided by the standard error of beta naught will give the t value for the beta naught, and you just have to copy paste and you get the t value for the beta 1. And here we are going to the p value. To calculate the p value in LibreOffice Calc, we have a wonderful function tdist. Use tdist and go for the t value and take the degrees of freedom. How many we have 20 data points in our study, and 20 minus 1, 19 is going to be the degrees of freedom, and degrees of freedom mode 1. And now the same you have to copy, but you'll get the error because you have negative value, so we just have to take the absolute value of that I can do in. So these are the t values. So if you observe the p values, it is very clear that the beta naught is significant, whereas beta 1 is not significant. The ideal the values for the constants, I mean the estimates, the ideal estimates need to be beta naught need to be 0 and beta 1 need to be 1. But whereas the theory says that the both of values must be equal to 0. In this case, the beta naught is significantly different from 0, and beta 1 is actually not significant. So if you observe the p-value, the p-value for the beta naught is less than 0.05, which means it is significant, and if we observe the p-value for the beta 1, it is greater than 0.05, which means at 5% significance level, so it is not significant. So this way we can test we can perform the regression analysis in LibreOffice Calc, and the overall relationship appears to be significant, because the beta naught is significantly different from 0. The fixed factor is significant, and whereas the beta 1 is not significant, so it is as expected. So there is not very much error between the variable y and x, and that we can go through the correlation, that we can just we can take the square root of coefficient of determination here, and this is r square. If we take the square root, it is 0.29. So approximately 20% of the variability in y is explained by, 8% of the variability in y is explained by x, whereas the relationship between y comma x is 0.3. So it is positive but poor. It's okay. 0.3 is okay. Actually, we have a positive relationship between y comma x. So that is the reason why the beta 1, the slope, though it is not positive, but it is not significant. It's little expected, as expected, but beta naught is not expected. Okay, thank you.